Let's take a look at your MT8 LT7 seminar on exponential equations. First thing, do the first 5 questions. Want to go over those in class. And what we're going to do is we're going to solve exponential equations. Let's take a look at a short video about what an exponential equation is.
You might notice that in the fall and winter, the flu virus spreads rapidly. At first, it seems like only a few people have it, but then suddenly, half of your class is out sick. Generally, the flu starts by infecting one person, and that person spreads the disease to a couple of others. Then, each of those people spreads it further. The number of people being infected grows faster and faster. This type of growth can be described with an exponential equation.
So when we solve an exponential equation in Algebra 1, we're going to make bases the same. There are other ways to do this, but this is the way we're going to do it in Algebra 1. You'll learn about other ways in Algebra 2. So you need to make the bases the same. Always change the bigger number to the smaller number. So let's take a look here at example 1. I want to rewrite 625 as a power of 5. In other words, I think, hey, what number, or 5, you just gave me the answer. Well, I want to use 5 because I got 5 to the x over here. That's how I know figure out 5. Now, 5 to the what power gives us 625? Well, that's 5 to the 4th. We've done that before. That's from our table when we started doing exponents with negative and zeros. So in other words, if the bases are the same, then the exponents are the same. So in other words, it's that simple. X equals 4. Not a lot of work to show on that one. Now, on example 2, you might have to use your power of power and your other rules. Notice, my bases are not the same. I need to make them the same. I'm going to make the bigger one smaller. So I'm going to say 3 to the what power gives me 27. Well, that's 3 to the 3rd. That's a cube, because the cube root of 27 is 3. Now I'm going to raise that to the x minus 1 power. I'm going to rewrite 3. I'm going to put my exponent there just to be on the safe side. Now when you take a power to a power, we multiply. So we're going to distribute the x minus 1, or the 3 to the x minus 1 actually. So that'll be 3 to the 3x minus 3 power equals 3 to the first power. Once again, my bases are the same. So that means my exponents are the same. So that's where I get my equation. I'm going to say 3x minus 3 equals 1. Add 3 to both sides. 3x equals 4. Divide by 3. And there's my answer. X would be 4/3. And that's what we get for an answer. Now let's take a look at example 2. It says in the 1950s, scientists proposed a space station that could house a crew of about 80 people. The station would be produced by artificial gravity by rotating the space station according to this formula. W equals GR. G is the gravity in feet per second. R is the radius of the space station. If the station's required a rotating speed of about 64 feet per second. Now, this is not just science fiction. Well, it is science fiction. But if we take a look at this clip from the 2001 A Space Odyssey, you can kind of see what's going on here. Got this nice music. And there's the space station and it's rotating, so it's producing artificial gravity so people won't float around. So what we're going to do is we're going to solve this equation. And we're going to find what the radius of that space station would be. So W equals the square root of GR. G, I know from my problem, is 32 feet per second. So I'm going to rewrite that as the square root of 32R because I'm looking for the radius. I want the speed to be 64 feet per second to simulate the gravity on Earth. Now, how in the world do I do that? The bases aren't even close to being the same, are they? So what we're going to do is we're going to make the bases the same. First thing I do, I'm going to get rid of that square root. I want to work with exponents. So I'm going to say this is 32R to the 1/2 power, because 1/2 we know is square root. Now, 32 goes into 64, I get that, but I can't take a power of 32. So let's go all the way back. Let's do the basics. I know I could rewrite 32 as a power of 2. 2 to the 5th power is 32. 2, 4, 8, 16, 32. So I have 2 to the 5th times R, raise that to the 1/2. And then 64 I can write as 2 to the 6th. Oh, there we go. Now I've got a little bit nicer with the same bases. So let's distribute that 1/2. So 2 to the 6 equals 2 to the 5/2 times R to the 1/2. Well, notice I can divide 2 to the 5/2 to both sides. So if I take 6 minus 5/2, which was really 6 minus 2.5, isn't it? But I'm going to write it as a fraction. So 6 minus 5/2. Well, let's actually show the work here. 6 minus 5/2. That'll be 12 over 2 minus 5 over 2, won't it? Because 6 times 2 is 12. So I get 7/2 power. I run out of room here. I'm going to write that in the second column here. So I'm going to say 2 to the 7/2 power equals R to the 1/2 power. So to get rid of that 1/2, I'm going to square both sides. So I don't have an exponent anymore. 1/2 of 2 is 1. 7/2, it's kind of hard to read, isn't it? I'm going to rewrite that. So 7/2 times 2, that's 2 to the 7th. At this point, let's use our calculator. 2 to the 7th power is 128. I put 2, I meant R, sorry about that. So R equals 128. That would be the radius of your space station. Think about that. That's not very big, is it? 80 people in a circle with a radius of 128 feet, they'd be on top of each other. Pretty, if we think about that, what is pi times r squared? So if I take pi times 128 squared, you get about 51,471 square feet. And if I divide that by 80, each person has 643 square feet of living space. Which seems like that'd be like a classroom size maybe. But we got to throw in the equipment there and the power. Yeah, you'd be kind of on top of each other, not a lot of room to work. So I don't know how realistic that would be for 80 people. Maybe if you notice our International Space Station, which does not have partial gravity, that doesn't have them. There's not 80 people up there at a time. There's probably usually what I've seen between 10 and 20, and that's even a lot would be 20. It's probably less than that. Probably could look that up. Okay, let's work on your MT8 LT7 assignment in your textbook.